Um, Good everyone, thank you for joining again for today's class. In the previous video that I did on simultaneous equation using the elimination method, we discovered that we only solved a very simple problem, and in this problem the coefficients of the unknown variables were the same in both equations, so it was not really a problem for us to find our way through the solving and get the answer. But in this video I want us to solve simultaneous equations where the coefficients of the unknown term or algebraic term are not the same in both equations. So we're going to know how to find our way through that kind of simultaneous equation. So let's just make room for that. I'm going to move this out of the way so we can do it for today. Sorry. Alright, so let's attempt another question. Let's say we have 3a plus 2b equal to 10, and then we have 4a minus b equal to 6, and this is equation 1 always, and this is equation 2. Now let's eliminate a in this simultaneous equation. You realize that the coefficient of a in equation 1 is 3 and the coefficient of a in equation 2 is 4. Now the coefficients are not the same. Now how do we find our way around that? Now it's very easy. If you want to make the coefficients of any algebraic term the same in both equations, all you need to do is you multiply the coefficients of that term in equation 1. You multiply, or rather let me put it this way, you multiply the whole of equation 1 with the coefficient of that term in equation 2, and then you multiply the whole of equation 2 with the coefficient of that term in equation 1. That means we are going to multiply equation 1 by 4 because the coefficient of a in equation 2 is 4. That's why I'm multiplying equation 1 by 4, and then we're going to multiply equation 2 by 3 because the coefficient of a in equation 1 is 3. I think that's very clear. And we are going to multiply everything. Don't make a mistake of multiplying only 3a and 4a. You are going to multiply everything in both equations by the specified number or value there. So let's begin the process. We're going to multiply the whole of equation 1 by 4. So 4 times 3 is going to give us 12a, plus 4 times 2 will give us 8b, 4 times 10 is going to give us 40, and then 3 times 4 is going to give us 12a. Now the coefficients are the same, and that's the goal of everything we just did. 3 times b is going to give us 3b, 3 times 6 is going to give us 18. Now the sign of the coefficients of a in the first equation is positive, and is also positive in the second one, so we are going to subtract, right? When we subtract, 12a minus 12a is going to give us 0, so that's by the way. And then we have plus 8 minus 3b. Now minus is going to give us plus 8 plus, sorry, this is plus 8b. 8b plus 3b is going to give us 11b. So that's how we're going to have positive 11 as our answer. And then 40 minus 18 is going to give us 22. Alright, so we have 22 there. Then b is going to be equal to 22 divided by 11, and b is going to be equal to 2. So that's how we have 2 as our answer there. It's coincidence that all the simultaneous equations we solved so far have 2 as their answers. Okay, so now I want to show you something. If you have solved for one of the variables in any of the equation, you can easily substitute it into the other equation and get your answer. Alright, that is a very easy way of doing that. Let's say we can pick any equation, let's say from or rather, let's put this in a better way. Let's say substitute b equal to 2 in equation, let's choose any one. Let's choose equation 2. In equation 2, and then we have from equation 2 you have 4a minus b is equal to 6. We have 4a minus, now b is 2, so we're going to replace it, equal to 6. 4a, by collecting like terms, 6 negative 2 crossing the equality sign becomes positive. 4a is equal to 8, and then a is equal to 8 divided by 4 and then a is also equal to 2, and then we have gotten the roots of the equation as b equal to 2 and a equal to 2. But let's try solving this with the elimination method one more time, so it's going to be very clear. But keep it in mind that a was equal to 2, so let's see if we get the same answer by using the elimination method. So let's write this equation: 3a plus 2b is equal to 10, and we have 4a minus b is equal to 6. Now our goal in this one is to eliminate b, and then the coefficient of b here is 2, the coefficient of b here is 1, so we are going to multiply equation 1, this is equation 1, this is equation 2. We are going to multiply equation 1 by 1 again here by 1, and then we're going to multiply equation 2 by 2, because the coefficient of b in equation 1 is 2 and the coefficient of b in equation 2 is 1. So alright, for equation 1, since we're multiplying through by 1, it's still going to be the same way it is, because 1 times anything is still that same number. So we have 3a plus 2b is equal to 10. Then if we multiply equation 2 by 2, 2 times 4 is going to give us 8a, 2 times b is going to give us 2b, 2 times 6 is going to give us 12. Alright, and that's very simple. So since the sign are not equal, are not the same, we're going to subtract, we're going to add, and then 3 plus 8 is going to give us 11a, 2b plus minus 2b is going to give us 2b minus 2b eventually, which is equal to 0. So 2b minus 2b is going to cancel out, and then we have 10 plus 12, which is 22, and then a is equal to 22 divided by 11, and a is equal to 2. Alright, so finally we have a equal to 2, and b is equal to 2 as well. And that's how we solved the simultaneous equation using elimination method. I believe the teaching and the video was very clear. If you have any questions, you can drop your questions in the comment section, and also do well to subscribe to this YouTube channel for more videos as this. God bless you.